Okay guys, so a train accelerates from rest to a speed 3 meters per second. It continues at this constant speed for a certain time and then decelerates uniformly to rest. If the average speed for the whole journey is 5 v over 6, show that 4/5 of the whole distance is covered at constant speed. Okay, uniformly to rest. Alright, so I'm going to go with a velocity time graph. Any idea why I do that? One object, three different phases of motion. So what you have here is you have your acceleration phase, you have your constant velocity phase, and then you have your deceleration phase. Now, if I was to break this up into 3 segments or 3 distances, distance x, distance y, and distance z, and let's call the entire distance d. Total distance is d. What am I being asked to prove? Using the letters on the board. Well, that's a given because yeah, right? Because all the different distances added together equal the total distance. Okay, but if you read the language, show that 4/5 of the whole distance is covered at constant speed. What would that mean? Y equals 4/5 d. Alright, so that's what we're looking to figure out. Now, it gives us absolutely nothing. It only gives us that the velocity is v. Okay, but it gives us an unusual thing in like average speed. We've never really dealt with that before. But roll back to your junior cert. What is average speed? Distance over time. So I think we can use that. Okay, so speed equals distance over time. Okay. So, what we're going to get is total distance over total time. Okay, so what I'm going to do is total distance over total time. I have actually. Alright guys, I'm going to have to introduce some times, okay? So we're going to have T1, T2, and T3. Okay? So, speed, which is 5v over 6. Going to equal distance. Now, how do we get distance? Find the area of each section, right? So it's going to be the first one's a triangle, which is a half base per height. Second one, rectangle, which is T2. Third one, a half T3, all divided by technically all over the total time, which is going to be T1 plus T2 plus T3. Okay? So what happens now, guys? We just got to, I suppose, cross multiply. But what else can I do here? What can cross off both sides? What can we get rid of straight away? I get rid of the V's. Can anybody tell me why I can get rid of all the V's? Everything on the top line to the left is being multiplied by v. Everything on the top line to the right is also being multiplied by v. So the v's can cancel straight away. Or if I was to factorise it out, I would have got v into a half t1 plus t2 plus a half t3. And that equals 5v over 6 technically, and all over t1 plus t2 plus t3. So just the v's will cancel each other out. Okay? So I'm going to cross multiply now. So when I'm at this stage, what I need to do next is I need to cross multiply this part here. So what I need to do is multiply 6 by everything here and multiply 5 by everything there. So it's going to be 5 into T1 plus T2 plus T3, and that's going to equal 6 times a half T1 plus T2 plus a half T3. So have a look at this here. We're going to get 5T1 plus 5T2 plus 5T3 equals 3T1. So 3T1, 6T2 and 3T3. Okay, we should isolate one variable. We can isolate T2, we could isolate T1, it doesn't really matter. I usually tend to go with the middle one, the one that's the rectangle. So I'm going to isolate T2 when I can. So what I'm going to do is bring the 5T to the left, becomes minus 5T2. Going to bring the 3T1 to the right, becomes minus 3T1. Going to bring that 3T3 to the left, which will be minus 3T3. So on the bottom I'm going to get T2, and that's going to equal 2T1 plus 2T3. Now, why did I isolate T2 in this example anyway? What we said at the start of the question was that we had to prove that show that 4/5 of the entire journey. So we need the time of this section here to find the distance of this section here. Okay, that's why we did that. That's why we decided to isolate T2. Okay, so what we have now is that T2, therefore T2 on its own is 2T1 plus 2T3. Okay, that's no bother there. Okay, so now we've got that information out. We got to whip this out and concentrate exactly on the region we want. Like that, we don't. Okay, so what we got to do next is we have to find out the fraction of distance that's covered at this speed. Okay, so we want to find out the fraction of distance. Now we tell me how to find out the fraction of distance. So the rectangle basically, what is this distance or fraction? It's going to be the fraction. The fraction is going to be equal to distance y divided by x plus y plus z. So it's just y over everything else, the three of the distances added together, okay? So, what is y? Y is Pt2. X is a half Pt1. That's Pt2. And Z is a half Pt3. Now we're at this stage here, okay? And the first thing to cancel, anyway, tell me what cancels straight away there. Same as last time, the V's are gone. So all the V's cancel. Okay, so all the V's are gone. Now, anyway, tell me what my next move should be.
Sub in the value for T2.
Yeah. We can get rid of two variables for the price of one, technically, can't we? See T1 plus T3. If I was to somehow isolate T1 plus T3 using this original formula here, I could get rid of it and put in T2. And then I'd have nothing but T2. So what I'm thinking of is this. Because the opportunity has only presented itself now. Same coefficient, T1 and T3. So if I isolate a half into T1 plus T3, I can say that, let me see, what would that be the same as? That would be the same as, well, I'm going to say that's the same as a quarter 2T1 plus 2T3. Does everybody understand what I did there? It's if I half 2T1, 2T3 is the same thing as a half T1 by T3. And 2T1 plus 2T3 is T2. So it's the same thing as a quarter, T2. So I'm going to replace, it's going to be T2 divided by this part here, and this part here now becomes a quarter T2, and this part here comes T2, and now it's going to be T2 all over 5/4 T2. The T2's cancel. What's 1 divided by 5/4? 4/5, and that's what we're asked to prove. 4/5 of the entire distance. Okay.